All right, let's do a packet tracer demonstration. I'm using the new packet tracer 6.0, and I'm going to configure this simple network with IPv6 and get the hosts communicating with each other and configure the router's interfaces for IPv6. So first of all, let's demonstrate IPv6 with these PCs here. So if I click on PC1, and I'll go over here to the IP configuration window, and you can see now in Packet Tracer 6 we have the ability to configure IPv6 on our PC. Now by default the device already has a link local IPv6 address. You can tell it's a link local address by the fact that it starts with this FE80. Alright? And the rest of these numbers were actually generated from the device's MAC address. We can see this if we open up a command prompt, and you can see I've already put the command in. I'll just put it in one more time, ipconfig/all, and you can tell right here physical address, there is the MAC address, and if you compare it with the link local address, you'll notice that the numbers are included in here. Notice BD/DAD, right? BD/DAD. Then in the center, to create the 64-bit interface ID portion of this address, the FFFE was inserted, and then the front half of the MAC address, 009021, is put in the front portion, except if you convert this portion to binary and you flip the 7th bit going from left to right, this 0 changes in the hex to a 2. So there's also a 7-bit switch that happens. The result is you've got the link local address that's been generated from the device's, let's say, MAC address. And that's what's happened in this case. That's what we see here, right? So the link local address allows the device to communicate on the local network. And any device on an IPv6 network needs to have, at a minimum, at least a link local address, right? So let's see if it works. And if it works, we should be able to copy this address, right? Copy. So I copy the link local address here. And if this works correctly, and this device has a link local address, and this device has a link local address, and they're connected to a switch, they should be able to communicate with each other on the local network using IPv6. And so I'll open up PC2, and in PC2 I'll go to the IP configuration window, and you see it has a link local address also. But I'm going to open up the command prompt, and right here at the command prompt I'm going to type ping and then a space, and then I'll right click and paste the IPv6 address of PC1. So now I'm trying to ping from PC2 to PC1, and let's see if it works. I'll hit enter, and you can see that in fact I'm getting replies, so that worked out. Alright, 4 echo requests, 4 echo replies using IPv6. So now that we've verified that we can communicate with the link local addresses on PC1 and PC2, let's bring up this router. Now the router will not have automatic link local addresses enabled, and in fact the router has IPv6 routing disabled by default. So we'll have to do some configurations on this router to get this router to play along in our IPv6 network. So I'll click on the router, and I'll stretch this out so we can see it a little bit easier. Alright, and I'll type in no so that we can just go straight to a router prompt. I'll type enable to get to privileged user mode, and then conf-t to get to global configuration mode. Now in global configuration mode, the first thing that we're going to want to do is type IPv6 and then unicast-routing. If we do that, that enables IPv6 unicast routing on the router. So without it, IPv6 is basically disabled by default. So now that we have our IPv6 routing enabled, we need to go to our two interfaces, and we have interface gigabit 0/0, you can see it here, and we have interface gigabit 0/1. This router is the new 1941 router that you can use in the new Packet Tracer 6. So this is nice, a 1941 router. It has gigabit interfaces. So let's configure those with link local addresses. So I'll type interface, int, which is short for interface, G0/0, and that puts me into interface configuration mode. And I can type IPv6, and I can manually configure my link local address. Now with the PC, it automatically self-configured, and we could do this here if we wanted to, but in the curriculum, they recommend configuring a more simplistic link local address so that it's easier to remember and work with. Now, link local addresses are only locally significant, so you'll see what this can do. So we can say IPv6 address and then type in FE80 colon, and instead of putting in like a MAC address or doing an auto configuration, I'm just going to say colon colon and then put in a 1, and then I can type in link. I'll hit the tab key and you can see it finishes the command for me. So the full command is IPv6 address FE80 colon colon 1 link dash local, and this creates a manual link local address on the router. And in the curriculum, the 1 is significant, let's say, for just the fact that maybe it's easy to remember, or the fact that this might be router 1 or R1 in the curriculum. At the end, I'm going to need to type no shut for no shutdown. So now the interface is up, and it has a link local address of FE80 colon colon 1, and that's much easier to remember because it's shortened, because all of the zeros in the IPv6 address can be abbreviated with just the double colon, right? So that looks pretty good. Let's do the same thing for the next address. So for the next interface, I can say interface gigabit 0/1, and I can do the same thing. And in fact, I can use the same link local address on the other interface. Since these link local addresses are only locally significant, they don't need to uniquely identify one network from another network. So I can just use the same address on the other interface, and that makes things even easier. So now both interfaces on the router have a link local address of FE80 colon colon 1, and we can test it out by, you can see here that it's beginning to come up. The router's lights here on the interface ports are turning green, and the switch port is coming up. You can see it's orange. It was red, now it's orange. It's going to be green in a second. And I'll just go to PC1, open up the command prompt, and I'll type ping FE80 colon colon 1. I'll hit enter, and you can see that we get a reply. So now we're able to communicate from the PC to the gateway using IPv6. If we go to the other router, we can also do it. So I mean, if we go to the other PC, PC0 here, which we haven't even talked about yet, we can also reach the gateway. We'll just go to PC0 here. You can see that by default it has an IPv6 link local address, meaning we're ready to go. All we have to do is just ping the gateway, FE80 colon colon 1, and you can see that we're getting replies. Now you might ask yourself, okay, so this is up and this is up. Can PC0 ping PC1 with link local addresses across the router from this network to this network? Well, the answer to that would be no, because link local addresses are only significant on the local network. They're only used for communicating on a local network. They're not routable. So let's give that a try. So I'll go to PC1 again, and I'll grab that address. There it is. Right-click, copy. And just to prove that it won't work, got to test things out. Command prompt, ping, and we'll put it in here. And you can see that we're not going to get replies. We can't ping from one network to another network using a link local address. And you can see we've got requests timed out here. And that's not going to change. So I'm going to close the window. So in the next video, what we're going to do is, now that we've got our link local addresses correct, right, and this router has a link local address on each interface, so we'll just put that here. It's got a link local address here, and it has the same link local address on the other side. Now what we need to do is configure the devices with routable global unicast addresses. And so we need to configure the router with a routable global unicast address, and the PCs also need global unicast addresses, and so I'll do that in the next tutorial.